This is lesson 45B, which is part 2 of our 2 lessons on adders. You remember in the last lesson we designed a full adder and used 4 of them to add 2 4-bit binary numbers. In this lesson we want to talk about the difference between carry and overflow. We'll do it by adding some 8-bit numbers. Now you remember that 8-bit numbers can be thought of as either unsigned numbers from 0 to 255, or they can be thought of as signed numbers ranging from minus 128 to plus 127. And remember, the leftmost bit here is the sign bit. If it's 0, then it's a positive number. If it's 1, it's a negative number, which is just a 2's complement of the corresponding positive number. Now the important thing to remember is that the carry bit only has meaning when you're thinking about unsigned numbers, and overflow only has meaning when you're thinking of signed numbers. You'll get a carry bit, that is an overflow as an unsigned number. The carry bit would be set if the correct answer is over 255. You'll get the overflow bit set if, as a signed number, it's outside the range minus 128 to plus 127. So let's see how it works. Suppose we want to add this decimal number 53 to 25. The answer is 78. In hex, 53 is 35. In hex, the decimal number 25 is 19. If you add 5 and 9, you get 14, which is E. 3 plus 1 is 4, so 4E is the hex value of 78. Let's do this binary addition here. 1 plus 1, you remember, is 0 with a carry. 1 plus 0 is 1 and a carry. This is going to give you 1 and no carry. 0 plus 1 is 1 and no carry. 1 plus 1 is 0 and a carry. 1 plus 1 is 0 and a carry. Then we have 1 plus 0, which is 1 and no carry. Note there's no carry from bit 6 to bit 7 here. And then 0 plus 0 is 0, and there's no carry out. So the carry bit out is 0. Well, it's 0 because 78 is less than 255, so this is the correct unsigned answer. Here it is, 4E, just as we would expect. However, the overflow bit is also 0 because 78 is inside the range minus 128 to plus 127. So thought of as signed numbers, this is a positive 53, this is a positive 25, and the answer is positive 78 decimal, which is correct. So the overflow bit is set to 0. Now note that we had no carry from bit 6 to bit 7, and we had no carry from bit 7 into the carry bit. And any time that happens, the overflow bit will always be set to 0. All right, let's do another example. Suppose we add 53 to 91. We add these, the answer is 144. 35, 91 is 5B. B plus 5 is 16 is 0 with a carry. 90 hex is in fact 144. So let's do this binary addition again. 1 plus 1 is 0 with a carry. 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 1 plus 1 plus 1 is 1 with a carry. 1 plus 1 is 0 with a carry. 1 plus 1 is 0. Notice we're getting a carry from bit 6 to bit 7. Then 1 plus 1 is just 1, and there's no carry. So the carry bit is 0, indicating that 144 is the correct unsigned answer, less than 255. And the result, in fact, is 90 as it should be. But what about the overflow bit? Well, in this case, the overflow bit will be correct because look what we've done. Thinking signed, if we think of these as signed numbers, we've added 2 positive numbers. This number and this number, they're positive numbers. Sign bit is 0. And we got a negative result. Well, that can't be correct, so the overflow bit is set to 1. The correct answer, which is 144, is outside the signed range minus 128 to plus 127, and that's why you get the overflow bit set to 1. Now note that we had a carry from bit 6 to bit 7, but no carry from bit 7 to the carry, and any time that condition holds, the overflow bit will always be set to 1. Alright, let's try another example. Let's add 53 to negative 45. In this case, the correct answer is 8. Minus 45, if you do the 2's complement, you'll find it's D3. Here's D3. And if you add these together, you see you get 8. D is 13 plus 3 is 0 with the carry. If you ignore the carry, then you get the 8 here. Well, let's see what happens when we add these. 1 plus 1 is 0 and a carry. 1 plus 1 is 0 and a carry. 1 plus 1 is 0 and a carry. 1 plus 0 is 1 with no carry. 1 plus 1 is 0 and a carry. 1 plus 1 is 0 and a carry. 1 plus 1 is 0 and a carry. So we get a carry here from 6 to 7. And then 1 plus 1 is 0 and we get a carry out. Well, we got a carry out because thinking unsigned, D3 is a big number. I mean, it's bigger than 128, obviously. And when we add this, we get 108. So we got a carry here because this is really 256. The correct answer here is going to be something like, 264 or something. So the number 8, which appears in this 8-bit sum answer, is wrong as the unsigned answer. The unsigned answer is bigger than 255. On the other hand, notice that 8 is the correct signed answer if you're thinking of this as a signed number, so the overflow bit will be 0. So thinking signed, we added this positive number, 53, to a negative number, negative 45, and we got the correct answer, 8. And so the overflow bit here will be 0. Therefore, the overflow bit B is cleared to 0. Because the correct answer, 8, is inside the range minus 128 to plus 127. Now, note that we got a carry from bit 6 to bit 7 here, and we also got a carry from bit 7 to the carry. Anytime this condition holds, the overflow bit will always be set to 0. Let's try one more example. Suppose we want to add negative 98 to negative 45. The correct answer is negative 143. This is 9e in hex, D3 in hex. If we add these, we get 171. If we ignore the carry, again, let's try this and see what happens. 0 plus 1 is 1 with no carry. 1 plus 1 is 0 with a carry. 1 plus 1 is 0 with a carry. 1 plus 1 is 0 with a carry. 1 plus 1 plus 1 is 1 with a carry. 1 plus 0 is 1 with no carry. 0 plus 0 plus 1 is 1 with no carry. Here, 1 plus 1 is 0 and a carry. So now the carry bit is set to 1 and the overflow bit is set to 1. Well, why? Well, the carry bit is set to 1 because obviously if you add 9(3) as an unsigned number and D3 as an unsigned number, the correct answer is going to be over 255, and therefore the carry bit is set to 1. But thinking signed, note by the way that there was no carry from bit 6 to 7, but there was a carry from bit 7 into the carry. Thinking signed, we added these two negative numbers. Here's a negative number and a negative number, and we got a positive number. So that must be wrong. So the overflow bit is set to 1. The correct answer, which was negative 143, is outside the range of minus 128 to plus 127, and therefore the overflow bit gets set to 1. Anytime you have this condition with no carry from bit 6 to 7, but a carry from bit 7 to the carry, the overflow bit will always be set to 1. So, what's the upshot? Well, here is what we found out. Note that we had an overflow bit was set whenever we had a carry from bit 6 to bit 7, but no carry from bit 7 to the carry. It was also set when we had a carry from bit 7 to C, but no carry from bit 6 to bit 7. So the upshot is that the overflow bit is the exclusive OR of a carry from bit 6 to bit 7 and a carry from bit 7 to the carry. So that's how you can compute the overflow bit.